start recording. All right. So welcome everyone to our first VMOL seminar of the fall/winter quarter. We're all very excited to have Dr. Hiroshi Tsugawa here, who graciously is giving us this talk at midnight there. So very appreciative, and yeah, you have quite a big audience here today, so lots of people are excited for the seminar. Yeah, Hiroshi is coming from the Tokyo University of Agriculture and Technology in Japan. And yeah, as you all probably know, he's worked for a long time in the field of computational mass spectrometry, developing tools like MS-DIAL, which he'll be telling you about today. So yeah, without further ado, go ahead, Hiroshi.
Yes, thank you so much. And yes, I will skip the several slides because my talk was started a little bit later on the exact schedule. But yeah, thank you so much for giving me this opportunity. And I will actually, first of all, I will present the current MS-DIAL news to generate metabolomics data. And yes. So first of all, simply, I would like to introduce our laboratory website, Systems Omics Lab, and where you can, for example, download MS-DIAL program latest version. And our developers, especially the lead developer Yuki Matsuzawa, actually uploaded the latest MS-DIAL program 1 or 2 hours ago for this talk. And actually, you can download, for example, the kind of GUI version of MS-DIAL, so from the third part. Then, so I will quickly explain the kind of the environment of MS-DIAL program. And so actually, maybe as some of you may know, so MS-DIAL GUI version is only available in Windows. But at least in Linux and Mac OS, you can use MS-DIAL program as a command line tools. Then, so for example, you can download a command line version of MS-DIAL program from this download link as well. Then maybe the kind of feature of MS-DIAL or the advantage of MS-DIAL program is that you can actually import the raw data itself into MS-DIAL program instead of, for example, the common data format like CDF or XML. Then, for example, if you were the kind of analyst using Bulker type stuff, you can simply import .d folder type files into MS-DIAL program, something like this. So this is actually frequently asked questions in the users of MS-DIAL programs. And for example, even though, for example, you have folder type files like .d or Bulka or Agilent, or for example, Waters. So you can simply drag and drop these folder type files into MS-DIAL program. Then, and this program actually can accept several modality data files of MassBank data. Like recently, for example, we are very interested in using kind of different modality of mass fragmentation, like electron activated dissociation from SciX or oxygen attachment dissociation from Shimazu. And for example, current MS-DIAL program can also perform the proteome metabolomics data processing in addition to usual metabolomics or lipidomics data processing. And also, this program can now accept the mass spectrometry imaging data. And also, for example, if you are interested in PASEF or DIA PASEF of Bruker instrument, you can process such data in this MSIR program. Then, for example, about the fragmentation technique. So the current feature, latest feature of MSIR program is, for example, you can annotate the lipid structures in more in-depth way. Like if you are the users of oxygen attachment dissociation from Simadu, you can now annotate the double bond positions in addition to, for example, usual molecular space level annotation of lipids, which can be performed by collision-induced dissociation. So actually, when compared with collision-induced dissociation, where you can simply annotate the lipid like phosphatidylcholine 16018-1. For example, if you were the users of SciEx Xenotoph instrument, and you can annotate this same phosphatidylcholine species as phosphatidylcholine 160/181-9, meaning so the double bond is located at delta 9 position of this carbon acyl chains. Then by using, for example, this EAD MSMS technique, we applied this technique with the update of MS-DIR program. So we annotated, for example, this is very unique lipid structures, so-called very long-chain polyunsaturated fatty acid containing phosphatidylcholine, which is very enriched in retina cells. Then, so although I will not talk about the detail of analytical chemistry in this talk, but if you can enrich this kind of VLC PUFA PC by this kind of sample preparation way, so you can get a bit high quality EAD MSMS spectrum, then if you can get this kind of, actually the disadvantage of this kind of new modality of mass fragmentation is the sensitivity issue. So for example, EAD MSMS has lower sensitivity than that of, for example, collision-induced dissociation. So that's why we have to enrich lipids first. But anyway, so for example, by using EAD with MS-DIR program, so we could annotate as, for example, this very long chain polyunsaturated fatty acid was highly enriched in SN1 position of the phosphatidylcholine glycerol moiety and annotated as omega-3 fatty acids. Then, for example, you can annotate the localization of such very specific lipid species if you have the mass spectrometry imaging data in MS-DIR program. Then, for example, this result shows the kind of the alteration of lipid localization in between the knockout mouse and wild type mouse. Then, for example, this year we actually announced this MS-DIR program is ready for processing GT-scan DIA from SciEx machine, from SciEx company, where this kind of sliding technique for DIA is available. Then, for example, in the processing of this GT-scan DIA in MS-DIR program, you can, for example, filter the kind of, how to say, so now you can use the new deconvolution or filtering techniques to reconstruct the pure MS2 spectrum from DIA spectrum data by looking at the kind of Q1 axis product IO behaviors. And if you are interested in this kind of topic, you can simply check our latest preprint of MS Dial program. I forgot to put the QR code into this slide, but you can simply search the term of GT scan DIA and MS Dial program into the bio archive website. And for example, by using GT scan DIA with MS Dial program, and so for example, you can reconstruct the pure tandem mass spectrum like this, even though this kind of two metabolites are completely co-eluted with the same retention time. So meaning, for example, in this case, so these two molecules are eluted at the same retention time, and with only 3 MO-Barge Dalton differences. Then, so the original tandem mass spectra are something like this, and this mixed spectrum is actually kind of refined to this kind of tandem mass spectrum after the Q1 axis deconvolution program, which is available for GT-scan DIA. Then, yes, so I will start to present the MSDIR 5 program in this talk by using the demonstration data provided by GNPS group. Then, yes, before that, maybe I have to say one thing. So our Japanese group started new project, Shin MassBank project. So Shin means in Japanese new. So it's so-called new MassBank project hosted by Japanese grant, where we would like to, how to say, develop the kind of the MassBank environment, including, for example, the reanalysis environment of from raw data repository like metabolomics workbench or metabolites or massive data. And the kind of one topic in this MassBank project is to develop the novel data repository in Japan, so-called MB Post. And yes, so our group actually launched a new data repository, MB Post, hosted in Japan server, where you can upload the mass spectrometry raw data into MB Post. And actually, the host of this MB Post is the Shujiro Okuda, and he is also the developer of JPost and GlycoPost. And JPost is actually very famous repository in proteomics research field. And maybe some of you know the name of JPost if you are the researcher using proteomics technique. And also he's managing GlycoPost repository where you can upload the raw data, mass spectrometry raw data related to glycomics. And his aim is to create the environment of multiomics data processing, and so in the server side. Then in the future, so our aim, one of our aims is, yes, to develop such multi-omics data repository environment. Then we actually started. Then anyway, please check this MB post data repository if you are interested in. Okay. Then from now, I will introduce the several things. So, yes, from now, I will. Can you see this desktop?
Yep.
At your
Looks
side?
good.
Okay.
Yep.
All right. And I actually downloaded in total 13 raw data from massive data repositories. And then, for example, yes. Wait. MP numberings demo and yes. Oh, maybe here. Yes. Today I actually downloaded the latest version of MSDial program from our website. Then, first of all, so if you download MSDial program, the MSDial folder contains two exe files. So one is msdial.exe and another one is raw data viewer.exe file. And first of all, I always use this raw data viewer.exe to determine the threshold of peak abundance. So this means I will just show you. So for example, you can simply, for example, yes. Then, so this is stay bio mode and show. It's something like Proteo Wizard CMS. Then, but you can simply check the kind of the MS spectrum by this viewer. But the advantage of this data viewer is this one. So this program simply provides the peak detection results. And this x-axis means signal to noise ratio of peaks, and this y-axis means peak height value. Then red color means that these peaks have MS2 spectrum, and this blue spot means these peaks didn't have MS2 spectrum. That's why, for example, yes, so you can see, so okay, this peak spot, yes, this peak spot M over G 258 and retention time 1.48 is last peak having MS2 spectrum by looking at this peak height value. Then this is just my opinion. So the peaks which do not have MS2 spectrum are not meaningful very much for the metabolite annotations. So that's why, for example, if you can see, so this 1 point E, it's kind of 10,000, no, 100,000 peak height can be utilized as a minimum threshold for peak height in MS-style picking algorithms. Then just please remember this threshold. Then, for example, after, because the kind of threshold, this peak height is the most important parameter setting in MS-dial peak detection algorithms. So that's why I'm using this raw data viewer.exe to determine this kind of peak height threshold. Right, then I will just start this MS-dial program. Then you can simply click new project button. Then if you have the raw data in this directory, just please copy this directory here. Then just you can click next. Then you can drag and drop this one. Then for example, if you manage the metadata in the Excel sheet, you can, for example, simply you can copy this table to the Excel sheet, something like this, and you can edit the kind of sample type or class ID, something like this. Then you can, if after you edit the sample type or class ID values, you can paste this metadata information directly to MS-dial program. And you can simply check which ontologies is available in this other data type or acquisition type, something like this. Then, so because this raw data is coming from positive ion mode and already centroided, so that's why the default setting, I will use default setting in this data window. Then next, and what I always changed in the parameter setting usually is, first of all, I will change the kind of number of threads from the default 2 value to, for example, 20. Meaning, so 10 biological samples are simultaneously analyzed. It means MS-dial use 2 threads for 1 biological samples for data processing. So that's why if you type 20 into this number of threads, so 10 biological samples are simultaneously processed. Then, as I said, so please remember these things. So I will put this value into, yes, here. So I will put 100,000 amplitudes as a peaks minimum peak height threshold. Then I will skip several parameter setting today, and I always put the spectrum library files. So for example, in my case, so our laboratory prepares this kind of private version of tandem mass spectrum libraries, which contains NIST or, for example, public library like MONA, MassBank, GMPS, or sometimes so Metrolin database. Then, so although I uploaded or I distributed, I'm distributing this kind of publicly available spectrum records into our website. Our laboratory use this kind of private website, which contains commercial database like NIST 20 or NIST 23 recently. Then, so if you import this MSP spectrum files, you can set several parameter for the annotation. Then, for example, you can simply, for example, import the different MSP libraries, or you can annotate the peaks with the different parameters in the same spectrum library conditions. And if you are familiar with the metabol space of Bruker company, so simply this MSI program has a similar parameter setting environment. So you can import multiple MSP spectrum libraries, and you can set your own parameter settings. Then you can add the different annotation parameter settings for the same mass spectrum libraries, something like this. Then, yes, that's all. Yes, if you have the blank sample, you can pick this option where you can simply exclude the peaks having similar abundance of blank from the blank sample. Then, so just click run after you determine the parameters in MS-style programs. Then, so today I will use the processed data. Yes, I'm correct. Yeah. Yes. So actually, after I first processed this demonstration data, I realized so retention times really shifted among the biological samples. Then, so for example, you can see multiple spots having the similar tandem mass spectrum patterns in many retention time region, something like this. You see here? So it means simply the reproducibility of chromatogram illusion is a bit lower than what I expected. So that's why in this case, you can, in my case, simply, for example, where was that? Wait, 5.5 minutes and 104. 04. This one? Yes. So, for example, this cocaine peaks annotated by several reference libraries. So I believe this peak will come these are same, but the retention time is different among the biological samples. Then, for example, you can, for example, align the peaks then in the graphical user interface, and you can modify the peak area or peak heights by this way. And for example, yes, yeah, something like this. So after this manual modification, you can simply will get the kind of curated metabolome data if you can curate such all peaks manually by yourself, but it will take super long time. Maybe you need 1 week to curate all of detected peaks, for example. That's why MS Dial has an option to execute retention time corrections. Then if you tick this retention time correction option, then if you click run, so new window it will be generated before the kind of data processing is started. Then, so for example, in my case, so I prepared this kind of retention time correction reference libraries for this data processing. And I actually selected the anchor peaks that can be utilized to correct retention times. Then, so as a demonstration, I simply selected 7 peaks as anchor peaks. Then, so for example, this cocaine peaks is eluted around 5.5 minutes. Then this retention time drift is within 0.4 minutes. Then all samples should have this cocaine peaks more than maybe 1 million peak heights, something like this. Then if where is, sorry, please wait. Yes. Then, so if you click retention time correction button, then, for example, you can correct retention time shift for at least anchor metabolites. Then, so the retention time data points in between anchor points are interpolated by using this kind of curve fitting using the anchor metabolite retention time drift as performed in XCMS non-linear alignment algorithms. Then after this kind of retention time correction for data points are finished, you can reprocess the same data by using this kind of environment. After that, so for example, sorry, I will close this one and no. See, so after I click this reference matched button, so it, for example, after the peak alignment is finished without retention time correction, the number of detected peaks is something like this. And if you click this reference matched button, so MS-dial shows the peaks annotated by MSMS spectrum libraries. And the number of annotated peaks is around 2736, but this data has the kind of duplicate or redundant peak features. Then after retention time correction was applied to the same data set, for example, you can see lower number of detected peaks in total, the 1, 2, 4, 8, 7. Then if I click this reference matched button, so the number of annotated peak features becomes 1, 2, 4, 6, which is actually lower than the original values. Then you will not see this kind of redundant peak features very much in the after the in this alignment spot viewer. Then okay, sorry. Then actually in this MS-dial program, you can do, for example, principal component analysis like this way. See here. Then, but anyway, what I'd like to mention in this talk is, so after, anyway, for example, data curation is finished, maybe you can normalize your peak height by using internal standard compounds, something like this. But anyway, after this, you can export for example, I will simply prepare this temp folder like this. Then I will click. I will set this directory as an output folder. Then, so I would like to announce. So for example, if you are interested in MZ tab M common data format, you can tick this option to generate MZ tab M format file. And if you want to generate GNPS required as the kind of MGF file or peak feature table or some H files which are required for GNPS and GNPS2. So you can take this option as well. Then I click export button. Then yeah, something like this. So for example, you will see MZ tab M file in the output directory. And for example, in the Metabol analyst, you can simply directly import this MZ tab M to Metabol analyst. So yeah, there is the MZ tab M option. And if you choose this MZ tab M file here, then simply submit. I cannot connect to, I don't know, reserve. But I could actually process this MZ tab M 3 hours ago, but maybe there is a server issue currently at the site of Metabol Analyst, unfortunately. But anyway, you can import this MS-dial MZ tab M file to be used in Metabol Analyst. Then, for example, yes, this is for you. This is very familiar. GNPS, no, 2. So, no, let's go over and launch workflow. And if yes, entry and launch workflow, then I've already actually uploaded several files, to your server. Then you can simply, yeah, put several things. So like this, add, then several feature. Then you may, yes, I will do this anyway. The spectral feature table and input spectra, and maybe other ion source peak shape, something like this, can be utilized as a H file. Maybe that's all. Then yeah, we are actually super happy your group kindly created 2 versions of MS-dial output. One is from until version 4 series. Another one is version 5 series. But we didn't realize this one. So that's why, but anyway, today our group created, that's why our group created these two buttons. So actually GNPS FBMN is still available in normal GNPS environment. And if you want to use the first version of GNPS, just please tick this GNPS button. Then if you want to use GNPS2, just simply use this button. Then we actually checked this works well in the GNPS2 environment using MS-style output. Then I'm sorry, I'm not familiar with this kind of web application yet. So that's why in the future I want to learn about how to use this browser. But maybe yes, and one more thing. Sorry, I have to say this thing. So in the search button, yes. So there is, of course, our group support MassQL. And for example, this is very general query. So I just simply use this kind of very simple query. Then if I click this search by MassQL, then after this, so for example, if you click this unique ions, so MS-style browse the peaks having this 268 points, blah, 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 in the product ion spectrum. Then also our group also supports several third-party algorithms like, where is that? Yeah, MS Clean R from the Europe group, and Notamen data post-processing from Cutting Lab. Then, but I will not present this functionality in this talk, but we are very, how to say, our group is very, our group very appreciate your collaboration in the future as well. And yeah, we would like to develop or improve MS-style program so that this program can be utilized to improve the metabolomics research or lipidomics research field. And yes, that's all of my talk. And if you have any questions, I can maybe provide answers.
Awesome. Well, thank you so much. That was super cool. I haven't used MS Style a lot, but now I'm excited to try it out, and maybe lots of people on the call feel the same way. So yeah, with that, maybe we can give Hiroshi a round of applause. Thank you so much. We'll stop the recording now and move on to Q&A. I saw tons of questions in the chat, so I imagine yeah, we'll have a busy Q&A section. So thank you, everyone. Thank you, Hiroshi. And yeah, I'll stop the recording.